Radhe Radhe. So in this video, I'm going to discuss the Frequal problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will probably put the links in the comment section. I'll pin them. The problem statement is very simple. You're given a number n and you have to find an array such that the frequency of every element in that array is equal to the number of devices of that specific element. Okay, and the best thing about this is you have to find uh, it in such a way so that the number of distinct elements in the array is as maximum as possible. Okay, so in this specific problem, something that you have to notice is the value of a of I is in the range of this. Okay, and the value of n is in the range of this, or 10 to the power 4, I guess. Yeah, I think it was 10 to the power 4. Okay, it's 10 to the 4 into 2. Okay, into 2. So if you look into this constant very carefully and do some mathematical operations, so since this n is in the form of 2 into 10 to the power 4, so n by 2 will be lesser than equal to 10 to the power 4, right? And from 1 to 10 to the power 6, there are more than 10 to the power 4 prime numbers. Okay, and remember one thing, for all prime numbers, one is an exception, obviously. So for all prime numbers, the number of devices are 2, 1 and itself. So for every prime numbers, we can print the two prime numbers in a row, okay, together, and then the next two prime numbers, then the next two prime numbers, like this we can print it. So what we can say, so there are two conditions. Okay, there are two cases. Case 1, n is odd. Case 2, n is even. So if n is odd, so let's say the array of prime numbers will look somewhat like 2, 3, 5, 7, 11, 13, 17 and so on, right? So if n is odd, so remember one thing, as I told you, like if I want to take this 2 in the array, so I have to print it twice because 2 is having two devices. If I want to 3 in this array, so I have to print it twice. 5 also twice. Okay, so basically if I am just making the array with prime numbers, so it will be the length of the array will be even. So in order to make it odd, we can add 1 to it because the number of devices of 1 is 1 only. So if n is odd, first add a 1. Okay, add a 1 and then go for n is even. That is, after you have added a 1, so now what is the value of n? Because like you have, so let's say n was initially 3, so now you have added a 1, so you need 2 more elements, right? So the value of n becomes n minus 1, and n minus 1 is now even. So now comes the n is even wala part. Okay, and if n is already even, you can skip this part. So for this, as I told you, make a prime array and print every element twice. Okay, so basically for 2, n is odd, no, n is even, right? So it is going to be 2, so that is going to be 2 2, so it is going to be a 2 2. Okay, for 8, n is even, so we are going to find the first n by 2 or prime numbers, so that is 2 3 5 7, right? So it is going to be 2 2 3 3 5 5 7 7. Now if you look into this case, so it is 1 3 3 4 4 5 5 5, sorry, 4 4 4 and 5 5, right? But remember one thing, this is like the answer can differ from the given answer. So basically over here there are the number of distinct elements of 1 2 3 4, and over here also 1 2 3 4. So you don't need to worry about this. So basically find the a vector or array of all prime numbers from 1 to 10 to the power 6 and perform these operations. And remember, like if over here, if this was 3, okay, so if this was 3, would have just added a 1 at the beginning and it becomes possible. So that's it from my side. Thank you.